Hi, this is Karen Launchbaugh. I'm director of the Rangeland Center up at the University of Idaho, and many of you know that I've been working with the Western National for a number of years, and I'm really excited about this year's. Too bad we can't be out in this beautiful country, but I wanted to give you a few guidance of what this virtual Western National in cyberspace is going to look like. It's a lot the same as the previous one, but I'll show you where we're using pictures or videos. So let's start. First of all, we're going to start with an introduction, which is at 9 a.m. Mountain, 8 a.m. Pacific on Tuesday the 10th. Gretchen Hyde and Sue Poland are going to give us a little bit of an overview, welcome us to the event. Then we're going to start right in. Part one, which is the problems, that's the stocking rate problem, and then also the current issues problem. Dr. Hewlett is going to give us some overview of that. In each case, students will have a paper scorecard that they'll have a chance to write out their notes and do calculations. The information about the problem will appear on a screen, and April will walk through a little bit on the problems. And students will be given time to write out their scorecards, and then they'll hit a button on the screen, and that will take them to an electronic scorecard. It actually will just be a Google sheet. They'll take their answers from their paper card and put them into the electronic scorecard. It will look very, very much the same. And then they'll submit that, and they'll move to the next set, which is the current Rangeland issue problem. The same thing. They'll have a paper scorecard, which we will send to all the coaches on Monday. Students can use that to make their calculations, get their answers, make sure everything looks right. Then they'll go to the electronic scorecard, put their information in the computer, hit submit, and then they'll move to the field events. So here's what the field events. Okay, so I've mocked up an example out at near New Meadows up on Price Valley, and just go give you an idea of how this is going to look. When you come to the field, we're going to actually zoom right into the field, so you'll see the place, and we'll have some aerial images of the field. Myself and Jason Carl, who's a professor here at the University of Idaho, will talk to you about that. Jason is a professor who did the drone work, and he teaches a drone class, so he'll zoom over the site and give students an overview of what that looks like. And then we will on the site highlight where the different events were placed on the site. All students need to do when they're ready to go after we've given the introduction will be to click on, we're going to start with plant ID, that's part 2. So click on part 2, and that will be highlighted for them. Then they're going to go to the cyber world. They're going to go to the field in cyberspace. They'll have a paper document to write their answers down while they're in the field. So this is just an example. Here's what plant identification will look like. There will go to a place, there will be an image, and on the image will be 15 flags because there are 15 plants. And let's say, for example, that we got through plants 1 and 2, and now we want to know what plant 3 is. So here's plant 3. And if you click again, you'll see that this is a video. So we made videos of plants, and we tried to zoom right in on them so that students can see the characteristics. And these are on a black background in the field. We put a black background behind them. And students can replay this as many times as they want just by clicking on it. And then they can just click through all the plants, keep writing them down on their scorecard. And once they've written them on their scorecard, they'll be done in the field, and then they'll click a button that will transfer them to the electronic scorecard. And again, the electronic scorecards are going to look a lot like the paper card. Here's what the plant ID looks like. This time, instead of putting in just writing in names, we figured this is not really a spelling contest, and it's kind of hard to grade the many variations that you might have of some of these plants. So we've got a list where we've numbered the plants here, and the students will just take that number and put it in to identify their the specimen at 1 through 15. So they're going to use numbers for plants, put them in the column, and I hope it's really clear. We'll try to make it really clear in the card. And then they just have to check whether it's a grass for browse, perennial annual, native or introduced, and then what the forage value, desirable, undesirable. Those are just check boxes. They'll just check those. When they're happy and they've double checked their paper card and their electronic scorecard, they're going to hit submit scorecard. And when they hit that, they'll get another link to take them back to the cyber field and go on to the next part of the contest. So, for example, they've submitted their score. They're going to go back to the field, and they're going to go to site description. There's some variations in how we're doing site description this year because we can't dig soil holes, but we're using the electronic methods that myself or other range professionals would use in the field. So I'm going to give you some examples. Part 3 is site description. So we need to know the precipitation, soil depth and texture, the slope and aspect, and the biomass. Okay, for the different elements of part 3, some will be pretty easy, like part 1, what's the precipitation zone? We've written the precipitation zone on a piece of paper, and while we're out in the field, we took a picture of it so students can see the field in the background, they'll see the precipitation and a few other climate variables. Soil is a little more tricky since we can't dig a hole and it would be hard to do texture over the screen. So we're going to use the tools that we would normally use in the field as range professionals, and that's some web soil information sites. I'm going to show you how those work. We're going to use maps to determine slope and aspect. Again, Tyler, one of our interns here at the Range Center, is going to show you how to do that. And then finally, the herbaceous biomass, we've put some plots out on the ground. We've taken several high definition videos and pictures of those, so students will be able to explore inside those plots as much as possible. It won't be the same, but should be able to get a sense of what biomass is. So since we can't dig a soil pit at the virtual site, we're going to use a web resource, a soil web out of UC Davis, University of California, Davis. You'll be given a link. It will take you to a map, a soils map. You just need to click your cursor somewhere in the soils where the blue marker is, because that's where the plot is. Click it right here. And then over on the left, you'll see that a menu will come up. Look at whatever soil is the greatest percentage there. Some of them have more. This one just has one major soil. I'm going to put it right there, and then take a look at the soil. It will tell you how deep it is. It will tell you have an A, B, might have an A1, A2, A3, but your goal will be to find out what the soil texture is in the A horizon and how deep the soil is. The best way to do that is hit description and read through the description. It tells you that the A horizon here is a very cobbly loam. So this would be a loam texture. You can read through this whole description, and sometimes it's a little more detailed, but it will always give you that soil texture. Keep reading through it till you get to the restricting layer, and it will tell you how deep that soil is. So this soil is 15 inches deep. It is a loamy soil type in the horizon. It's a loam. So then we're going to go back to our scorecard and add the appropriate items. Okay, the next thing is to think about how you might do slope and aspect on the site, and Tyler is going to tell you a little bit more about that.
Hello, this is Tyler Ernst with the University of Idaho, and today I'm going to be walking you through how to calculate slope and aspect. I'm going to start with slope here, and how we're going to do this is we have a 100-foot transect set out between two different points of elevation. So the formula we're going to use here is we need to determine rise over run to calculate what the slope is, meaning that we're going to divide the rise by the run. And given the information that we have a 100-meter transect, so we know that C is going to equal 100 feet. To calculate A, the rise, we can take the differences between elevation, and that should come out to be about 30 feet. And so we've revised our model here. What we don't know is B, and that's what we need to solve for. And to do this, we're going to have to use a little bit of math, Pythagorean Theorem. So A squared plus B squared equals C squared. So now we've plugged in our model with the Pythagorean Theorem equation, and 30 squared is going to equal 900, and 100 squared is going to equal 10,000. So using a little bit of algebraic expressions here, we can subtract 900 from 10,000, and we now know that B squared equals 9,100. So because it's squared, we're going to take the square root of 9,100, and this is going to equal 95.38 feet. So the next topic is aspect, and we're going to use a tool that I've developed here for aspect. And here is this tool, and it's very important that the first thing you do when you see this tool is you need to orient the tool to the map. So you can see that there's an arrow here orienting the map north. So you're going to take your tool and push it over your arrow and make sure that you are oriented north. Now you can take this tool and move it over your line, and we can determine what direction the slope is facing, what aspect is. So we know that the downhill side is to the left and kind of down.
Thanks, Tyler. Thanks for creating this little tool, and it looks like the aspect, the bearing is 225. So then you can go back to your scorecard and see which category that fits in, and mark the score card to be transferred to the computer. After we've completed the site description, then we go to the next section, which is similarity to desired state. In the field, that's going to look like this. It's going to be 3 plots. We've got some pretty good imagery, so students can kind of zoom in on this, but this is mostly what they're going to do is just look at 3 plots, and we'll give them what the desired state is, and they'll make the comparisons just as they always do. They'll put them on their paper scorecard. They'll go to the electronic scorecard, put their information in there, and then submit the scorecard, and then they'll move back to the main site. So the next section is the browse age diversity. We have a site laid out there. We've got plants marked, and we took videos of all of those plants on a black background, and so students will be able to take a look at those plants and kind of move around them and see what they think the age diversity is of about 18 plants. Again, they're going to put their information on a paper scorecard, transfer that information to the electronic scorecard, submit the electronic scorecard, and they'll be back at the field. Landscape appearance, we have also taken lots of pictures of grass. Unfortunately, it's really hard to show utilization in a plot, so to be honest with you, I'm going to walk everybody through those different pictures of utilization. I know what we looked at in the field and how much biomass we removed, and when we got to kind of look a little closer at it, we were able to determine the category of use that each little plot had. So I'm just going to describe those and tell students what they are. So in this section, students will write down, we'll look at the plot, and I will tell them what I think the category is. They'll write that on their score. So this is really just going to be a matter of, can you use the data I give you in the field to make a calculation for the utilization. The last section is shrub cover, and that is also going to be in the field. Dr. Carl took his drone out there, and he took some great images of a line transect. So along that line transect, students will be able to zoom in, and they'll be able to, with a ruler on the screen, tell how many inches the plant is, to measure, and it will tell them how long the transect is, so they'll be able to just move their cursor and move down the transect. So that puts us back to the field, and then the students can just take one more chance to take a look at the site and then submit everything, and then they get to sit back for a few hours perhaps while we're scoring things, and then get back to awards at 3 p.m. So this is last year's award team with Hagerman, and the national winner also gets a silver belt buckle, which we have this year. So I hope that your teams do well. And thanks again for trying this virtual version of Western National.